This is all about stage interface. Here we are modeling only single blade row in each and every rotor or stator. So we shall choose stage mixing plane interface. Now click next. Here it has chosen the interfaces automatically. That is R1 to R1, where here there is a general grid interface present in the tip region of rotor. In the tip region there is a small surface in the center of the tip. That surface, it is not actually a single surface, it is two surfaces. This is created based on the turbo grid mesh output. So this is the surface on one side and this is the surface on the other side. So both the surfaces should be given some interface. Here there is no frame change option, so we can choose the type as none. The next one is R1 to R1 periodic. Here we have to specify circumferential periodic interface. Here by default CFX has chosen periodic interface for this R1 to R1 periodic, R2 to R2 periodic, and when it comes to R2 to S1, we can see it is showing stage interface. So between all rotor and stator domains there will be stage interface. The order may be jumbled, but all the interfaces are present here. Now click next. This is all about boundaries. So as I told, we have to specify wall boundary for all rotor, hub, blade, and similarly for status we have to specify the wall boundary for hub, shroud as well as blade. For rotor domains, in the shroud region it will be wall boundary with counter rotating wall option. It means the whole domain will be rotating, but in actual case the casing will be stationary. To simulate that, there is an option called counter rotating wall, so that you can model a stationary casing. This is the boundary of R1 blade, hub, R1 inlet. We have specified the boundary condition, R1 shroud, wall with counter rotating wall option, R2 blade, R2 hub, and all other blade boundary conditions. At the exit, it is 180 kilopascal average static pressure condition. Now click next and click finish. Now the case is almost ready. We shall specify the solver control parameters here. We shall keep the maximum iterations as 500. After convergence, we shall see if required we can increase or we shall retain at 500 itself. And residual target we shall change to 10 power minus 6. For RMS, until it does not specify any other interrupt conditions, we can leave other parameters by default and click OK. We can create some expressions to monitor the mass flow rate at the inlet outlet as well as pressure ratio, temperature ratio, and efficiency. Before that, I will quickly tell about the turbulence models which has to be specified for each analysis. If you double click this R1 domain or any other domain, in the fluid models tab you can see the turbulence. Here by default it is selected as shear stress transport turbulence model. But if you click this 3 dots, there are many other turbulence models present in Ansys CFX. So shear stress transport turbulence model is the standard turbulence model which commonly people use for validating their results. Now we shall quickly see details of turbulence models and then we shall come back to this case setup.